Just some quick feedback on the circuits lab that you did, since you're not getting that back before the test. For a circuit which you evaluate using Kirchhoff's voltage law, if you draw a loop like this, it's going to be marked wrong. So if you draw a circuit like a loop like that in order to apply Kirchhoff's voltage law. So this loop starts on one conductor, this one over here, that's the conductor, and it ends on another conductor, namely this one over here, the red conductor. And when you're doing Kirchhoff's voltage law, the loop has to start and end on the same one. So it starts here because that's where the, if I think of it as just a curved arrow, that's where the tail of the arrow is. So that's saying, hey reader, I'm starting here. And it ends here because that's where the arrowhead is. And you're saying, hey reader, it ends here. You have to start and end on a conductor. It's a good idea. Don't even start close to a circuit element if you can avoid it. So it's not a very good looking resistor there, but I'll call it R1 anyway, R2, and the CWMF. So for instance, start like somewhere on the conductor. I like to start at a corner of it, but pretty far away from that CWMF, for instance, which is the closest circuit element, and then go all the way to the end right there. You can put a little dot that says this is the start, and then the arrowhead says this is the end. You don't need the dot. There's number 1. Actually, before you do that, you should have like defined a current. Put minus and plus. Short side gets the minus, the long side gets a plus for a CWMF, and then for a resistor it goes in the high side. The current flows in through the high side, not the low side. If somebody asks you which way it goes through a resistor, you don't say through the high side, because no matter which way it's flowing, it's going to flow through the high side. You want to say it enters via the high side and exits via the low side. Alright, so suppose you did that, and maybe you call this V1, V2, and then you went to apply Kirchhoff's voltage law, KVL, on loop 1. So I'm going to write down something that's wrong. Be careful that you realize this is wrong. I'll put an extra out as quickly as I can afterwards, but suppose you wrote down V minus V1 minus V2 equals 0. Now, you might say, by some measure it's right, but the problem is it's not telling me that you know what you're doing. It's like, I don't know if that you just got lucky and guessed that that was the right equation, or if you just went out of order with your loop. I am not going to give you the benefit of the doubt on that. You're going to lose points if your equation is not exactly consistent with the loop. So the loop starts here. The first thing it goes through is resistor R1, so the first thing I should see is minus V1, and then the next thing should be minus V2. And remember, this loop is just a finger tracing loop. The current, that symbol represents actual flow of charge, something that's going on in the circuit. This is just a calculational tool. I think of it as just dragging your finger around the circuit. When you experience a change in voltage, there's one, you put it down, plus V. Oh, and when you get back to the conductor that you started on, you say equals 0. You're essentially saying the potential difference between a point on this conductor and a point on this conductor is 0, which is of course the case because all points on an ideal perfect conductor are at one and the same potential. So this one is okay. I understand the argument that, hey, this is equivalent to it. The two equations are saying the exact same thing, but I still insist that you put it in the order that's consistent with your diagrammatic representation of the same equation. That's it on the feedback. I told you it was going to be just a little bit.